this is Romero again, and I'm going to continue my science experiment on chromatography. My previous problem, whenever I eat M&Ms and Skittles, I always think they're going to taste the same because of their colors being similar. However, in the end, their taste is completely different. After some thought, I posed this question. How are the colors or dyes in Skittles and M&Ms different? My hypothesis was that if I use the separation method, chromatography, on the green M&Ms and the green Skittles, then this will reveal that the separated colored green dyes of both candies are the same. In order for me to figure out if my hypothesis is true or not, I would have to do my own chromatography experiment to separate these two candies' green dyes and see their concentration, distinguishing differences or similarities between dyes. So, let's get started in the experiment. Okay, so first off, we'll be needing materials in order to conduct this experiment. So let's jump into that. For this experiment, we'll be needing Skittles and M&Ms, more specifically the green kind, where we will have 2 pieces for each candy.
I modified the original experiment slightly and used 1 piece of candy for each, which does not change or tamper with the experiment in any way.
Here next to the candy is the aluminum foil that we'll be needing. We'll be needing 2 separate pieces so the dyes won't cross-contaminate. Next to it is the water, or 3 cups worth of water for the chromatography solution. And right next to that is the dropper we'll be using so we can drop water onto the aluminum to place the candies in order to separate the dyes. Then toothpicks, 2 separate toothpicks to place the dye onto the filter paper. And we'll be using a pencil, and by no means a pen, because the liquid ink, which is made of dyes, can contaminate the candy dyes, ultimately compromising our results for the experiment. Then we'll be needing 2 coffee filters to place the dye on, along with scissors to cut the filter paper according to the measurements that will be discussed in the procedure. We have a metric ruler to measure the filter papers in order to cut them, along with to measure the distance the solvent will travel, and to measure the spacing and the location where the dyes will be placed. Next to it is salt, or 1/8 of a teaspoon of salt, to make the chromatography solution. Next to that is 2 clear cups to pour the chromatography solution in, and is where we'll be hanging the filter paper over. And right next to that is the last 2 items, which is the 2 mini binder clips to put the 2 straws through to hang the filter paper over the water. And this should be all the materials we need to follow through the experiment. Before moving on to the experiment's procedures, these are my variables. First off, we have our independent variable, which is the candies themselves, because it is what is going to be changing in our experiment, where we will test 2 different candies, M&Ms and Skittles. Our dependent variable is going to be the concentration of the dyes. In other words, how far the dyes travel up the filter paper, because this is what we are going to be measuring. For our control variables, we have the usage of a pencil for labeling and marking the filter paper to not contaminate the dyes and compromise our end results, since It doesn't bleed into the dyes. We have the same color candies. Any measurements with a metric ruler we have in the procedure. So there's the length and width of the filter papers. This next one is not really a measurement with the metric ruler, but it is important to keep controlled, is the distance the filter paper will be submerged in the water. There's the spaces between the dye's placement on the filter paper, the same distance of water should stop at, which is half a centimeter from the top. And every measurement that we do in this experiment is in centimeters. This includes our recording of the results. We have the usage of the same water for our chromatography solution, in which we'll use the same amount. The same goes for salt. We have to use the same salt as well as the same amount. The time each piece gets to be in the drop of water on the aluminum foil, and to use the same amount, which is 1 drop each candy piece. The same aluminum, but different pieces of aluminum for each candy, so we won't contaminate the dyes. We have the different toothpicks, one for the M&M's dye and the other for the Skittles, again because we don't want to contaminate the dyes. The same amount of dye on the filter paper, where we let the same amount of time to dry, and the same amount of the number of times we reapplied to the filter paper. The same filter paper or coffee filters. And the reason why I have so many controls is because I feel these variables may affect the results of the experiment or change what is supposed to be tested. And we know that we have to keep our experiment as controlled as possible so we get the best results and valid results.
Okay, for the procedure of the experiment, we are going to start by doing some prep work, starting with the filter paper strips. With the filter paper we have here, we're going to make our filter paper strips by measuring two 6x8 centimeter rectangles. Where we are going to make sure the edges are as straight as possible as we cut them. On the bottom of the strips, using the ruler, we'll be measuring at the bottom of the strip 1 centimeter and marking it with the pencil with the line across it, where at the line we dot the strip at the 2 centimeter and 4 centimeter of that line, while at the top we measure half a centimeter, also marking it with the line. Afterwards, we will label one strip M&Ms and the other Skittles. Next is prepping the candy's dyes. To remove the dyes from the candies, we start with cutting out two small 5 by 5 centimeter pieces of foil. Place 1 drop of water on top of each of those 2 pieces of foil. Place a green M&M on top of 1 piece of foil. Doing the same for the green Skittle on the other piece of foil. Then we'll wait about a minute for the candy color to seep into the water. After that minute, the dye will look like this. So, following through is the process of dyeing the filter papers. To start, we need to dip a toothpick into the green M&M dye we made earlier and dab both the above areas of the filter paper labeled M&Ms where we made the pencil line where the dots are at 2 centimeters and 4 centimeters. The same process is done to the other filter paper labeled Skittles. For each strip, we let it dry for about a minute. This process of dabbing the dye onto both strips of filter paper is repeated for at least 4 times. And this is what it would look like after the repeated process for both strips of filter paper. Shortly afterwards, it is time to make the chromatography solution. In order to make the chromatography solution, we need to pour 3 cups of water into a container and add 1/8 teaspoon of salt. After that, we pour some of the solution into each of our clear cups, leaving the liquid about 4 centimeters deep, depending on what size cups you have. After making the chromatography solution, we need to make the hangers we will use to hang the filter papers. To make these hangers, we need to put a straw through the triangular center of each binder clip. Next is clipping the M&M and Skittles filter papers onto each binder clip with the die dots at the bottom. Finally, we can start our experiment. First off, let's start by hanging the filter papers on top of the glass so that the bottom of the filter paper is just touching the water. Now, we wait and watch. Once we see that the water has traveled up to the half centimeter mark on the top of the filter paper, we will remove them from the cups with water. After removing the strips from the cups of water, we will set the strips aside to dry, or afterwards we can record our results of the measurements of the distance the dies traveled on a table, as well as making any final observations as a side note. As we can see on my table, I listed the sources of the dies, green M&Ms and Skittles, where I will record the distance traveled of their dies over 3 trials, with each candy in the trial having 2 of their own mini trials because each filter paper strip had 2 dots each. The following results of the trials will be put into this table and will be converted into a graph to compare and contrast the dies distance traveled. Here are the final results, and here they are in a graph. From the results in the table and from the graph, we can see that the M&Ms was consistent in staying high in distance and almost seems as if it was gradually getting further in distance, while the Skittles was consistently dropping and only spiked in the second trial and having a long distance traveled. On average, the green M&M dies traveled 5.35 centimeters, while the Skittles die traveled 5.15, which is a 0.2 centimeter difference, which is a small margin. In addition, in my final observations, I saw that both candies' dies had the same color bands of yellow and blue. In conclusion, since the margin of the distance traveled between the 2 candies' dies was small and were very close, along with the bands of the colors being similar, the candies' dies are the same. This shows that my hypothesis of the dies being the same correct, rather being different. Maybe next time, if I try this experiment again, I can either use other colored candies to explore other colored dyes to see if their dyes are the same or not, or find other candies that are green and extend this experiment on green dyes to see if all green dyes are the same or different.